All right, guys. Start out with today. What I'd like you to do is kind of build on what we talked about the other day with even or odd or maybe neither functions. So I've got three equations on here. What I'd like you to try to do is I want you to identify, are we dealing with an even function, an odd function, or is it neither for that function? And then have an idea of, okay, how would I explain why I chose what I chose for that? So why don't you work on that one, pause the video, and then come back and see what you should have for that. All right, let's talk about even, odd, or neither functions again. Essentially, there's kind of three things that we can look at when we're trying to make this decision. So on the first one, one way we can check this is we can plug in the opposite of x and then see, see what we get when we simplify. So if I were to simplify this, I really have y equals negative 2/3 x plus 1. So if this were an even function, I would have had the exact same equation. So I know evens out. If it's an odd function, I should have the exact opposite of what I started with. Well, I almost have that because I do have negative 2/3, but I still have a plus 1. So that would not be considered the opposite output. So this one's not odd either. So this becomes a neither situation. All right, so that's one way we can check it. A second way that we could check it, say I'm looking at this second situation. I can look at the graph of the function. So let's go to the graph of y equals x plus 2 squared. And so when I look at the graph, the first thing I'm going to do is check to see if it's even. Well, if it's even, that means that we should have a line of symmetry here at the y-axis. It's not very good y-axis, but you get the idea. Well, if I were to reflect that over the y-axis, I do not get the exact same graph. So this one is not an even function. The second thing I check is if I rotate this 180 degrees, do I get the exact same graph? Well, when I did that, it's not the exact same graph. So that means it's not an odd function. So it turns out this function fits in that neither category as well. So I can check for even, odd, or neither by putting in the opposite of x and seeing what the output looks like. I can look at the graph itself and decide, do I have a line of symmetry at the y-axis? If so, it would be even. Or can I rotate it 180 degrees and have rotation symmetry? If that happens, it would be odd. But if neither one of those things happen, then it's the neither category. All right, the last thing I can do to check to see if I have an even, an odd, or neither function is maybe the easiest way. So let's take this last equation, the one that has the absolute value of x, minus x squared. Well, another way I can check it is I can look in the table of values. And when I look in my table of values, what I'm going to look for is what's happening when I have an input that's negative versus when the input's positive. For instance, when I look at this table of values here, when the input was -4, I had an output that was negative 12. When the input was positive 4, I had an output that was the same. It was negative 12. When I had an input of negative 3, I had an output of negative 6. At positive 3, I also had negative 6. I can double check another one. Negative 2 gave me negative 2. Positive 2 gave me negative 2. So in other words, the opposite x value gave me the same output. Well, anytime that happens, I would say that this is an even function. Had I got a situation where, say, negative 4 was negative 12 and positive 4 was positive 12, and negative 3 was negative 6 and positive 3 was positive 6, well, that would have been an odd function because they would have had the opposite outputs. If I check negative 4 and it's negative 12, and I check positive 4 and it's like 27, well, that would tell me it's neither. So I've got 3 ways to check it. I can input that negative x, I can look at the graph, or I could look at the table of values, and then I can make my decision from there. I'm okay with any of these 3 unless they actually tell you which one to use, but you just have to explain what your reasoning would be. All right, something else I wanted to go through. This was actually one of the homework problems, number 128. On part B for A and B, but the one I'm going to go through is B. They talked about trying to find the x-intercepts, the y-intercepts, the locator point, and finally the graphing form for this situation. Well, when you first look at the equation, it may not have jumped out at you what kind of function you're looking at. So in order to make that decision, what you probably would want to do is you want to simplify this as far as I can. So I'm going to try to get rid of all the parentheses, combine like terms, and then see what kind of equation we're looking at. So if I multiply this out, I'm going to have 2x squared minus 4x plus y. And I probably want to get y by itself. So I'm going to move everything to the other side. So I had x squared. If I subtract 2x squared, I now have negative x squared. I had negative 2x on this side when I put it together. So when I bring it over, it's going to be positive 2x. All right, so this is my equation. So first of all, what type of function am I looking at? Well, I'm looking at a quadratic function, or my graph is going to be a parabola. All right, so let's find the things they asked me to find. Well, one of them was x-intercept. Well, x-intercept is when y is equal to 0. So I'm going to try to factor this. The nice thing is this one has an x in common, so I'm going to factor out an x. When I do that, I'm left with negative x plus 2. So my 2 solutions here are when x equals 0 and when negative x plus 2 equals 0, which means if I subtract 2 and do the opposite, I'm looking at when x is 2. So my x-intercepts are at 0, 0 and at 2, 0. All right, let's do y-intercept. Well, that's when x equals 0. So this actually works out pretty nicely because when I put 0 in for x, I just end up with 0. So my y-intercept was 0, 0, which we already kind of knew because that was the same as one of my x-intercepts. All right, then the last thing they wanted to know or wanted us to do was to write it in graphing form. So if I write it in graphing form, remember in general, that's this form. So I'm trying to take this equation and get it into that form. All right, well, we already know the a value because notice it has a negative sign out in front. So I already know a is negative 1. So I'll kind of keep that in mind. We said we could find the vertex a couple ways. One way we could find the vertex is we could average the x-intercepts. And so if I average 0 and 2, that means I have an x value of 1. So already I know this was -1, and now I know that x is 1. So to find our k value, or the y part of the vertex, I'm going to plug 1 into my equation. So if I did -1, and then I squared that 1, or the opposite of 1 squared, 2 times 1, well, that's going to be -1, because keep in mind it was this situation, plus 2, which means I'm going to have 1. So I could have used the averaging the x-intercepts method. Excuse me. I also could have tried to complete the square. Now, if I were going to complete the square, I'd really probably want to pull that negative out. So if I did that, I'd be left with this. Then I'd think about taking half of the 2. Now, notice on this one, we didn't have a constant over here. So when I square the 1, that's going to give me 1. I'm going to multiply that by -1. So now that's -1, but I really wanted 0. So I had to add 1, and I get to that same equation. All right, so just a different way of looking at it, because it may not have been apparent when you started what kind of function you were looking at. I put 128 there, but I'm not sure this one was 128. This was another problem that you had to work on. I don't think it was 128 though. Anyhow, this one, they gave us a parabola. They said the vertex was at 3, 5. They said it contained the point 0, 0. And they said in part A, if the parabola is a function, find its equation. Well, so far, that's all we've worked with are parabolas that were functions. So I'm going to try to fit it into my equation. They gave me the vertex, so I know I'm going to try to do graphing form. Well, this is like what we did the other day, so I'm going to plug in the coordinates of the vertex. So I now have this, y equals a times x minus 3, because we went 3 to the right, plus 5, because we went up 5. Well, now I need to figure out my a value. That's where 0, 0 comes in. So I'm going to plug that point in. I'm going to plug 0 in for y and 0 in for x. And now I'm going to solve for a. So remember, probably best bet is to take care of this 5 first. So I'm going to subtract 5 to the other side. -3 squared will be 9. And so my a value is going to be -5/9. So our equation here, -5/9 x minus 3 squared plus 5. So hopefully that one wasn't too bad. The second one, though, may have been confusing because we haven't had a chance to talk about this yet. Because part B says, suppose the parabola is not a function, but it is a sleeping parabola. They want us to find that equation. Well, we're going to hold off on finding this because we don't know what a sleeping parabola is yet. So let's start with that. Let's start with, all right, well, what is a sleeping parabola? Well, if I ask you to take this equation, x equals y squared, and graph this equation. Well, the first thing you may notice is, well, this isn't a y equals equation. And ordinarily, especially if I'm putting it into my calculator, I need a y equals equation. So let's think about how we could solve for y here and then maybe put this into our calculator. Well, to get rid of the squared, we know we'd have to square root both sides. So if I were to square root both sides here, I'm going to get y on this side. However, we got to keep in mind when I square root this, I really have two things that could happen. I could have a plus or minus square root of x. Or in other words, I really kind of have two things here. I have the positive square root of x, and I have the negative square root of x. So let's see what that graph is going to look like. So I'm going to enter in two different equations. I'm going to put in the square root of x, and then I'm going to put in the opposite of the square root of x. And I'm going to graph that. And notice what we end up with here. We have a parabola that is not opening up or down, but now is opening to the right. And this is what we will refer to as a sleeping parabola. Because that parabola is laying down. Now notice the sleeping parabola still has a vertex. Its vertex for the parent graph is still at the origin. And what we're going to look at is, well, how could I make adjustments to the sleeping parabola like I did when we had our regular parabolas? You know, things like how do we shift it left and right? How do we move it up and down? Can I stretch it or compress it? Instead of making it open to the right, how could I maybe make it open to the left? So we're going to see what's going to happen when I try to make some of these changes. All right, well, let's say I gave you this equation. I said x equals, because now I know it's a sleeping parabola, negative y plus 1 squared minus 3. So this is an adjustment to a sleeping parabola. And we want to see what this parabola is going to look like. Well, if I wanted to, I could rewrite this one and get it in y equals, but probably a better way of attacking this one is to go to Desmos. So I'm going to pull up Desmos. And I'm going to enter this equation in. So x equals, oops, maybe. The opposite of y, and I've forgotten it already, plus 1 squared. Minus 3. Okay, so let's notice some of the things that have happened here. First of all, let's see where the vertex is at now. So if I look here at the vertex is now at, let's see, here's negative 4. So here's negative 5. So it looks like negative 3. And these are worth a half as well, negative 1. Notice also this one is now opening to the left. So let's see if the equation could have told me this. Well, first of all, the opening left, you probably guessed, was from this negative sign. So if there's a positive sign out front, it's going to open to the right. If there's a negative sign out in front, it's going to open to the left. So since I'm thinking left and right, it's really thinking about reflecting over some vertical line. Then I have an x value that's negative 3. And notice that matches what we had here on the outside. I had a y value of negative 1, which really comes from this part. Well, notice inside parentheses it said plus 1, and that became a y value of negative 1. Outside the parentheses was minus 3, and that's what our x value was. So really it's just the opposite of what we had done in the past when we had a regular parabola. We still make our adjustments. It's just now notice the y values on the inside of the parentheses, the x values on the outside of the parentheses. The positive negative tells me which direction it's going to open. All right, well, what about stretching or compressing? Let's say we took this graph and I threw a 5 out in front. Well, every time we had a number bigger than 1, it always made it more narrow, or we stretched it. And notice that still is the case here. We ended up with a parabola that was more narrow than it was before. However, we didn't stretch it vertically or up and down. We actually stretched it horizontally, side to side. And that's why it became narrower than what it was before. How do I make a number less than 1? 0.2. Notice it's compressed. It's gotten wider, but the compression wasn't up and down. The compression was horizontally. It was side to side. So really what we're doing is kind of retraining our brains and thinking just the opposite of what we had before. So let's say that I ask you to sketch this sleeping parabola. Let's say we had 3 times y plus 4 squared minus 1. All right, so just like when we had a regular parabola, I'm going to pick out where the vertex is located. So the vertex, the x values here on the outside, so negative 1. The y values here on the inside, since it's y plus 4, we do the opposite, so negative 4. So that's where the vertex is located. I'm going to try to decide, does it open to the left or right? Well, this is a positive 3, so that tells me it opens to the right. And then I'm going to think, does it have a horizontal stretch or compression? Well, 3 is bigger than 1, so we know that that's going to stretch it. Or in other words, it's going to be skinnier. So if I were to sketch this one, be at negative 1, negative 4. It's going to open to the right, and it's going to be a little bit thinner than normal. So that would be our sleeping parabola. Now, notice our sleeping parabola is not a function. If I were to take a vertical line and I move this vertical line, notice it hits my graph in more than one point. So in other words, there's 2 outputs for certain inputs. And that means this is not a function. So this is one of the 2 non-functions you're going to look at today. So if I were to go back to that problem from the homework, where it says, suppose this parabola is not a function, but it's a sleeping parabola, that means I'm really trying to fit it into this equation. Now, instead of A, I'm going to use B, because we're not stretching up and down, or stretching side to side. It's not x minus h, it's now y minus k squared plus the h. Well, remember, the vertex on this one was at 3, 5. So I'd have, to start with, x equals y minus 5, because the y value is 5, plus 3, because the x value is 3. Remember, it went through the point 0, 0, so steps now are the same as what they were in the past. I'm going to plug 0 in for x and y on this one. And now I'm going to solve for b. So I'd subtract 3. Negative 5 squared is 25. And so my B value would be negative 3/25. So my sleeping parabola would have this equation, negative 3/25 y minus 5 squared plus 3. So if I were to sketch this one open to the left because of the negative. It would be compressed horizontally or wider horizontally because of the 3/25. And we already knew the vertex was at 3,5. All right, so one of our non-functions we're going to look at is going to be the sleeping parabola. The second non-function you're going to look at is going to be a circle. So I have an activity that you're now going to look at that you're going to use Desmos for again, and you're going to answer some questions related to circles.